po rin siyempre ang simula si Benny. Si Benny Lobato na talaga namang sexy. At si po ang bida din hindi nagpapahuli. Lahat na nakakasama at relate dito sa Poutech. What's up guys? Welcome to Poutech. Are you ready for today's episode? Me too! I'm so excited because all our segments for this episode is about structural geology and rock mechanics. Uy, rock mechanics? Structural geology? Ano yun? Ay nako, that's basic.
Structural geology, scientific discipline that is concerned with rock deformation on both a large and a small scale. Its scope of study is vast, ranging from submicroscopic latticed effects and crystals to fault structures and fold systems of the Earth's crust. The methods of structural geology are nearly as diverse as those of the geologic sciences as a whole. Structural geology is the study of the three-dimensional distribution of rock units with respect to their deformational histories. The primary goal of structural geology is to use measurements of present-day rock geometries to uncover information about the history of deformation, strain, in the rocks, and ultimately, to understand the stress field that resulted in the observed strain and geometries. Structural geologists use a variety of methods to, first, measure rock geometries, second, reconstruct their deformational histories, and, third, estimate the stress field that resulted in that deformation. Geometry's primary data sets for structural geology are collected in the field. Structural geologists measure a variety of planar features, bedding planes, foliation planes, fold axial planes, fault planes, and joints, and linear features, stretching lineations, in which minerals are ductilely extended.
Ah, yun pala yun. O siya, simulan na natin ang series. Our first segment is called May Attitude Ka. Did you know that sedimentary beds have attitudes? These beds are deposited in horizontal layers, so if the layers are no longer horizontal, then we can infer that they have been affected by tectonic forces and have become either tilted or folded. Geologists take great pains to measure and record geological structures, and one of the key features they measure is the bedding's orientation, also known as the attitude. Kaya ngayon, kailangan nating alamin ang attitude ng bed na to. Feeling ko, masungit yan. Di namamansin, no? Tapos, tingnan mo pa, parang nakasimangot siya. Nani? Hindi mo yata naiintindihan eh. Ganito lang yan.
We can express the orientation of a bed or any other planar feature with two values. First, the compass orientation of a horizontal line on the surface, the strike. Second, the angle at which the surface dips from the horizontal, perpendicular to the strike, the dip. Measurement of geological features is done with a special compass that has a built-in clinometer, which is a device for measuring vertical angles. Strike and dip are also used to describe any other planar features, including joints, faults, dikes, sills, and even the foliation planes in metamorphic rocks. Figure 12.20 shows an example of how we would depict the beds that make up an anticline on a map. Another way of representing strike and dip is by dip and dip direction. The dip direction is the azimuth of the direction the dip has projected to the horizontal, like the trend of a linear feature in trend and plunge measurements, which is 90 degrees off the strike angle. Apparent dip is the name of any dip measured in a vertical plane that is not perpendicular to the strike line. True dip can be calculated from apparent dip using trigonometry if the strike is known. Geologic cross-sections use apparent dip when they are drawn at some angle not perpendicular to strike.
And that's the attitude of beds. Naalala ko tuloy bigla yung outcrops. Pero ayun naman, rock layer or formation that are visible on the surface of the earth when exposed by weathering and erosion. Hey, that's also interesting. Tell us more. Oh, sure.
Rock which occurs at any given place on the earth is called that location's bedrock. In some cases the bedrock is actually exposed and is said to outcrop at the surface. Unfortunately, in many places the bedrock is covered by water, dirt, plants, pavement, buildings, or other coverings which obscure the area's bedrock. If there is no outcrop, it is hard to determine the local geology. Often all that a geologist has to look at is loose pieces laying about on the surface. We call these disconnected pieces float. As always, there are shades of gray between these two extremes. There are places where it is impossible to determine for sure that the exposed rock is connected to the earth and therefore bedrock. But it sure does look like it is, and therefore probably not float. We call this I don't think it's float, but I'm not convinced that it's attached material subcrop. The term subcrop is also applied to material which has probably broken off, but has not been moved from its original location. In most cases, subcrop is better than working with float, but not nearly as desirable as bedrock which outcrops.
Now, it's time for our next segment, Guess of the Day. At ang guest natin para sa araw na to ay isa sa mga pinakatanyag na civil engineer, geologist at explorer sa buong mundo. Walang iba kundi si Miss Dora! Hi, Miss Dora. I'm your biggest fan, and it's a pleasure to have you in our show. Thank you. It's nice to be here. Pero nahold up ako kanina habang papunta rito. Oh no. Ano nakuha sa'yo? Yung bag, pati map ko. Paano na yun? Don't worry, Miss Dora. Bibigyan ka na lang namin ng bagong bag sa map. Fine, but I want a Gucci. And the map should be a geological map. Geological map? What's the difference of that compared to an ordinary map?
A geologic map or geological map is a special purpose map made to show geological features. Rock units or geologic strata are shown by color or symbols to indicate where they are exposed at the surface. Bedding planes and structural features such as faults, folds, foliations, and lineations are shown with strike and dip or trimmed and plunge symbols which give these features three-dimensional orientations. Fold, permanent wave-like deformation in layered rock or sediment. fault, a fracture in bedrock along which rocks on one side have moved relative to the other side. Joint, a fracture on a rock without noticeable movement. Faulted areas are neither safe nor stable for the foundation works because of the various harmful effects produced by faults. Faults cause considerable fracturing and shattering of rocks along fault zones. This means that are not compact or massive or strong. Such places are reduced to physically very weak grounds and hence unfit as foundation sites for withstanding heavy loads of structures like dams. When such porous and fractured zones get saturated with water, their strength comes down further. Generally, faults are accompanied by earthquakes. Earthquake cause severe shaking of the groundwater. Such shaking may cause collapse of civil engineering structures. Since joint are a set of cracks or open fractures, they act as planes of complete breakage or non-cohesion. As a result, such a site is not compact, massive or coherent, which means that it is physically weak, inherently. Through this joint's water is likely to percolate and saturate the rocks. Further, this may cause decay of rocks along joint plane. Both these facts further reduce the physical strength of rocks considerable. This makes the region unsuitable for tunneling purposes also.
Okay, we'll give you a Gucci bag and a geological map later. Maliban sa pagiging geologist, pag-usapan naman natin ang pagiging civil engineer mo, Miss Dora.
True! Kasi kami, engineering students din kami. At gusto namin malaman kung ano ang importance ng structural geology pagdating sa engineering construction.
Use and important structural geology is a critical part of engineering geology, which is concerned with the physical and mechanical properties of natural rocks. Structural fabrics and defects such as faults, folds, foliations and joins are internal weaknesses of rocks which may affect the stability of human-engineered structures such as dams.
How about the term grouting in civil engineering, Miss Dora? Can you explain that to us?
Grouting in civil engineering refers to the injection of pumpable materials into a soil or rock formation to change its physical characteristics. It is one of the ways in which groundwater can be controlled during civil engineering works. Grouting is suitable where soil permeability would create a heavy demand on pumping or where ground conditions mean it may be economically inefficient to bore wells. There are several different types of material used for grouting. Cement or cementitious grout is used for grouting materials with a high permeability. Neat cement and water or a mixture of sand, 4 parts, to cement, 1 part, is the usual composition. Bentonite is produced from clay which has thixotropic properties, meaning it forms a highly water-resistant gel which, when mixed with additives, can create a permanent barrier to water flow. This is used where soil particles are too small for cement grouting, most commonly to combat seepage in alluvial soils beneath the foundations of dams or other water-bound structures. Chemical grouting is used in soils of medium to coarse grading. Materials such as sodium silicate and calcium chloride are mixed together in liquid form and solidified into a gel. Chemical grouting has the advantages of allowing economical spacing of boreholes, greater penetration of the grout, and more flexibility in terms of the time of grouting. As opposed to chemical grouts, resin grouts have a very low viscosity which are able to penetrate fine sands. The type of resin used depends on the chemical content of the local water table and may result in different times for setting. Bitumen emulsion can serve as a suitable grouting material that can be injected into fine sands as an impermeable barrier to water. Soil strength will not be increased, but cut-off walls beneath dams and other water-bound structures can be formed effectively.
Thank you for your time, Miss Dora.
You're welcome! Adios!
So, let's proceed to our third segment, the Q&A.
Yes! Alam naman natin lahat to, pero para sa new viewers natin dyan, you guys can ask us anything. Just go to Twitter and tweet us with the hashtag Poutech Q&A. And we'll pick one each of us are going to answer on our next episode.
And for today's episode, we're going to respond to this tweet by @Rockabye asking, can you choose the top 2 traits of or properties that you are looking for in a rock partner? They can be either physical or mechanical.
At dahil hindi naman lahat ng viewers natin ay tulad natin mga bato, sasabihin muna natin sa kanila kung ano-ano ba ang physical at mechanical properties natin.
Rock mechanics, physical and mechanical properties of rocks. The mechanical properties of rock play a vital role in the structures that form during deformation deep below the Earth's crust. The conditions in which a rock is present will result in different structures that geologists observe above ground in the field. The field of structural geology tries to relate the formations that humans see to the changes the rock went through to get to that final structure. Knowing the conditions of deformation that lead to such structures can illuminate the history of the deformation of the rock. Temperature and pressure play a huge role in the deformation of rock. At the conditions under the Earth's crust of extreme high temperature and pressure, rocks are ductile. They can bend, fold or break. Other vital conditions that contribute to the formation of structure of rock under the Earth are the stress and strain fields. Porosity is a measure of how much of a rock is open space. This space can be between grains or within cracks or cavities of the rock. Permeability is a measure of the ease with which a fluid, water in this case, can move through porous rock. Density is defined as the mass per volume. In rocks, it is a function of the densities of the individual grains, the porosity, and the fluid filling the pores. There are 3 types of density in rocks: dry density, wet density, and grain density. Dry density is measured on rocks without any water or fluid in their pores. Wet density is measured on fully saturated cores. Grain density describes the density of solid or mineral grains of the rock.
She tells him, ooh, love, no one's ever gonna hurt you.
Hardness is difficult to quantify. It is a measure of resistance to deformation, specifically permanent deformation. There is precedent for hardness as a surface quality, a measure of the abrasiveness or surface scratching resistance of a material. If the material being tested, however, is uniform in composition and structure, then the surface of the material is only a few atomic layers thick, and measurements are of the bulk material. Thus, simple surface measurements yield information about the bulk properties. Ways to measure hardness include Moss scale, Dory abrasion test, Duval abrasion test, indentation hardness. Indentation hardness is used often in metallurgy and materials science, and can be thought of as resistance to penetration by an indenter. Elastic deformation refers to a reversible deformation. In other words, when stress on the rock is released, the rock returns to its original shape. Reversible, linear, elasticity involves the stretching, compressing, or distortion of atomic bonds. Because there is no breaking of bonds, the material springs back when the force is released. This type of deformation is modeled using a linear relationship between stress and strain, that is a key relationship. Plasticity is the ability of certain solids to flow or to change shape permanently when subjected to stresses of intermediate magnitude between those producing temporary deformation or elastic behavior and those causing failure of the material or rupture. Toughness can be described best by a material's resistance to cracking. During plastic deformation, a material absorbs energy until fracture occurs. The area under the stress-strain curve is the work required to fracture the material. The toughness modulus is defined as the modulus is the maximum amount of energy per unit volume a material can absorb without fracturing. From the equation for modulus, for large toughness, high strength and high ductility are needed. These two properties are usually mutually exclusive. Brittle materials have low toughness, because low plastic deformation decreases the strain, low ductility. Ways to measure toughness include Page and Path machine, Charge impact test. Resilience is a measure of the elastic energy absorbed of a material under stress. In other words, the external work performed on the material during deformation. The area under the elastic portion of the stress-strain curve is the strain energy absorbed per unit volume. The resilience modulus is defined as...
So, ano na ang top 2 properties na gusto nyo makita sa partner nyo? Sige, ako na ang mauna dyan. Ang partner na hinahanap ko ay yung may porosity para kaya niyang mag-hold at hindi ako bibitawan. Sana. Plastic para kahit anong mangyari, hindi siya magbabago.
Ay, sa akin naman, mas gusto ko yung may permeability. Kasi ayokong dumating ang araw na mapuno siya sa akin. Tapos meron din dapat siyang plasticity. Kasi walang mali sa pagbabago, lalo na kung nagpasok ka for the better.
Basta ako, mas tumitingin pa rin ako sa density ng isang bato para mabigat ang pinaglalaban sa buhay tulad ko. At sa resilience, para kahit nakaka-absorb ng stress, nakaka-recover pa rin. Sana all, di ba? Maganda lahat ng points niya, pero alam niyo ba sa matigas? Na pwede kayong masandalan kapag may problema. At matibay kaya paniguradong hindi gigiba kahit gaano ka kahirap ipasan. Hardness and toughness ang para sa akin. Ayan, nasagot ka na namin at Rockabye Baby. Pero konting trivia lang sa ating mga viewers. Did you know that we also have dynamic properties as rocks?
Dynamic properties of rocks mainly include its typical properties. Modulus of deformation, Young's modulus, modulus of rigidity, shear modulus, modulus of volume expansion, bulk modulus, Poisson's ratio, bulk density, compressive strength and tensile strength. The wave theories and the factors influencing the wave velocity is also included.
At ang susunod naman nating segment ngayon ay tinatawag na Little Big Rocks, kung saan nag-feature tayo ng mga batang bato na talaga namang ahead sa kanilang generation.
That's right. And now, let's welcome our little big rocks for today. The young science geniuses, the illegitimate twins, Stony Stoneface and Pebbly Mac Pebble.
Rock, baby, rock. Rock it to my heart. Rock, baby, rock. Sing a never part. Hey, hey, hey. Hey, hey, hey.
Hello, Stony and Pebbly. Kamusta naman kayo?
Ay, try naman po! Ako po, super excited kasi first time ko pong ma-invite sa ganitong show. Ma! Pa! Artista na ako!
Tama. At sisigat kayo kapag ipinakita niyo sa amin kung gaano kayo ka-genius sa science.
Sure! Tanongin niyo lang po kami ng kahit na ano.
Really? Sige nga, what are the static and dynamic moduli of elasticity?
The dynamic moduli of rock are those calculated from the elastic wave velocity and density. The static moduli are those directly measured in a deformational experiment. The static and dynamic moduli of the same rock may significantly differ from each other. The main reason is likely to be the difference in the deformation, strain, amplitude between the dynamic and static experiments.
Wow! Ikaw naman, Stony. Tell me something about the bulk elastic properties of a material.
Bulk elastic properties of a material determine how much it will compress under a given amount of external pressure. The ratio of the change in pressure to the fractional volume compression is called the bulk modulus of the material. The reciprocal of the bulk modulus is called the compressibility of the substance. The bulk modulus of a solid influences the speed of sound and other mechanical waves in the material. This buildup of elastic energy can be released violently in an earthquake, so knowing bulk moduli for the Earth's crust materials is an important part of the study of earthquakes.
Young's modulus. Alam nyo?
Of course!
The description of the elastic properties of linear objects like wires, rods, columns which are either stretched or compressed. A convenient parameter is the ratio of the stress to the strain. A parameter called the Young's modulus of the material. Young's modulus can be used to predict the elongation or compression of an object as long as the stress is less than the yield strength of the material.
Baka po, gusto nyo rin itanong ang shear modulus.
The shear modulus is determined by measuring the deformation of a solid from applying a force parallel to one surface of a solid, while an opposing force acts on its opposite surface and holds the solid in place. Think of shear as pushing against one side of a block, with friction as the opposing force. The shear modulus is determined by measuring the deformation of a solid from applying a force parallel to one surface of a solid, while an opposing force acts on its opposite surface.
May gusto rin po kaming i-share na video.
At yun ay kung paano titest ang modulus of electricity ng isang country.
Grabe. Hands down. Kunwari may kamay ako.
Uwian na! May nanalo na! Maraming salamat sa inyong dalawa. At pinarealize niyo sa akin kung ano ko walang alam nung batang-bato pa ako. Salamat po! Thank you po!
And we're down to our last segment for today's episode. Pero ito ang isa sa all-time favorites natin dito sa Poutech. It's time to rock a song!
The ground will shake, 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 shake. Look at the floor, the vibration, shun, shun, shun. Primary waves compress, expand, span, span, span. The ground looks like an accordion, yan, yan, yan. First waves, cause they go on and on and on. First waves go on and on and on, yeah. An earthquake happens with no warning signs, saying ayo, the faults let go.
Body waves travel through the interior of the Earth. There are two types of body waves, P waves and S waves. The P and P waves stands for primary, because these are the fastest seismic waves and are the first to be detected once an earthquake has occurred. P waves travel through the Earth's interior many times faster than the speed of a jet airplane, taking only a few minutes to travel across the Earth. P waves are predominantly compressional waves. The S and S waves stands for secondary, because they are the second fastest seismic waves and the second type to be detected once an earthquake has occurred. S waves are shear waves, though that is not what the S stands for. Surface waves. There are two types of surface waves. Rayleigh waves are set off by the combined effect of P and S waves on the Earth's surface. Love waves involve the surface shearing sideways and then returning to its original form as each wave passes. Factors influencing wave velocity. A wave is a disturbance that transfers energy through matter or space. Waves travel through a medium. A medium is any substance or region through which a wave is transmitted. The speed of a wave is dependent on four factors: wavelength, frequency, medium, and temperature. Wave speed is calculated by multiplying the wavelength times the frequency. Types of waves. Transverse. The motion of the transverse wave is at a right angle to the motion of the medium. There is no net displacement of the medium. Every transverse wave has a crest and trough. Light, water, and guitar strings are all examples of transverse waves. Longitudinal waves. The motion of the wave is in the direction of the motion of the medium, parallel. These types of waves are also known as compression waves.
At ito na nga ang oras na kailangan naming magpaalam. Which segment of today's episode did you like the most? I like it too! See you next time here in